Hello there, ladies and gentlemen, and welcome to another video. Now, in this one, I'm going to be showing you guys just something that I've been working on, a nice project here. So if you're familiar with these Tapo kind of devices, so if you go onto like Amazon UK, for example, and then you search for like Tapo stuff. So there's like a bunch of, you can get like smart plugs and all that kind of stuff, the lights and stuff like that. And they're normally the cheapest out of all of the other options, and they're made by TP-Link, which is, a fairly reputable brand. So I have a bunch of these Tapo devices, right? But I can only control them from my app. Well, until this point, because they don't have like, a website that you can use or any kind of like desktop client. And the app is kind of, it's not the best. It's fairly shit. So what this project aims to do is you can like, monitor and control your Tapo devices using just like a standalone server. Now, this code that I wrote, it's heavily based on this repository here. This is made for Homebridge. Now, I don't know what the heck Homebridge is. All I did was I just went into here and then just looked at how he did, all of his code for like communicating with the devices. So I just took that and then I just added sort of my own kind of back end and then front end on top of that, instead of using the Homebridge kind of back end thing. So just using, simple Node.js for most of the stuff. So I have it running on my Raspberry Pi 2B at the moment. And I also have it running on a separate network. So I'll get into that in a bit later, how I set up the networking and all that kind of stuff. But I suppose I should just show you how it looks like right now. So if I were to go into 71, then port 3000. So there is a couple of UIs for this available. So this is the first UI here, just kind of, your standard, your standard web UI or whatever. I'm just gonna put in, so you should see my light bulb here in my room. And so that is the office light bulb. And I can go into here and I can change like, its colors like so. Change its brightness and everything here. And I can also change its color to like red and whatnot, green and stuff like that. So yeah, my camera is not the best, so that's why it looks a bit fucked, but I can tell that it actually looks green. So yeah, we'll just kind of set it to some normal color for now. Yeah, so this is the color temperature. So in the app, you'll see that you can change, the color temperature to make it more kind of daylight. So this will be here, kind of like quite bluish. And then here will be kind of like, orangish kind of color temperature. So yeah, that's how you can control it there. And you can control, the plugs as well. So for example, this laptop, I can just turn it on. Then if I just update this, you'll see that it's on. And if I keep on updating, this will update like every kind of second. So you should see the watts kind of change every second. And if I just turn that off, you should see that it should update. So, oh yeah, kind of need to press this again. Yeah, I'll probably update that so that keeps on going. Yeah, but anyway, then the second UI is actually the CLI, because CLI is the best UI. Yeah, so if you do node monitor client, so you'll get the same UI, but you can run it inside the terminal, and I'll just make that a little bit bigger for you boys. And so yeah, you can see this updates every 1 second as well, like so. Then you could see all of my devices here. Yeah, so my 3D printer at the moment is disconnected from the plug completely, so that's why you see an error here. So we'll log error messages. If something goes wrong, usually it's just timeout. Sometimes the IP address of these change it, and you'll get a timeout as well, but I'll show you guys how to get around the IP address changing. So yeah, it shows you kind of the main stuff, the current power usage and all that kind of shit. So yeah, we'll try that there. All right. Oh yeah, and then one last thing. There's also a nice Python script here that I wrote. So if I do v, actually, I kind of forgot the command. Where was it? Yeah, so v bin python tree, then screen bulbs. So what this will do is this will update this bulb based on what's on screen. So if I go here for a second and I open something like GIMP, this is just to get something on screen. So right now the screen is white, so this thing by default will show kind of that kind of color. But if I were to change it to, let's say, green, or actually let's go with blue, and I were to paint this whole thing, you should see that it changes to blue, like fairly fast. If I do yellow, it'll change to yellow. And so with this, what you can do is, let me just get out of that, go back here. Let me just pull up this 4K video, move it to another screen, open up this, mute the volume, and then if I play it, you should see that it should reflect the backgrounds if this ever changes. So it takes the average background color and then just displays it. Now it does it like in 100 by 100 pixel column, so you can see it like kind of change the color to the algae. Here I'll change, to blue. Here might change to green if it's green enough. Yeah, I suppose not really. Yeah, this is kind of a fucking shite. Let's try this one. So let's see if there's any. So yeah, that should. Yeah, so it's kind of like changing between green and whitish. If you could see it in the corner there. Yeah, this should change all right. Yeah, I suppose they're kind of similar colors. Because it is taking, the average. So yeah, if the average is kind of always whitish, it's not the best. But if we were to like pause on this boy here, like that should be somewhat red. Yeah, there you go. So yeah, it does take a while to update because it's running through a bunch of network hoops. For some reason, it really thinks that snake is blue. But yeah, it's kind of like a nice ambience kind of thing, even though it doesn't work the best. It's not too bad. Like usually if I'm watching a movie, it kind of enhances the experience a little bit since it kind of dims, your background with what's on screen, sort of. So yeah, it's pretty cool. You can also do this if you have multiple lights in your room. You can see how fast it updates there. If I go into the Python script here, and if we scroll to the top, so yeah, I can also do the same thing for my LED strip. But I'm not going to do that since you guys can't really see it anyway. So yeah, you can just enter like a list of your device IDs and it will work out, you know. So yeah. Also, to get your device IDs, by the way, is if you go into here, there isn't really a good way at the moment, but if you open up your developer tools, and if you head over to the office, and if you just do something like change the color, for example, you should see that there is a network request for this ID here. And all you need to do is just copy this ID and you can put it in here. Like so. So yeah, easy peasy lemon squeezy. So yeah, that's all you need to do to set that up. All right, so let's talk about how this actually works, because the way this is set up networking, the network is kind of interesting for me anyway. So I'm just going to stop this script. I'm going to open up GIMP again. So I can draw out kind of the network. Let's see, new folder here, should be fine. All right, so let me grab a pen here. Let me make it a little bit smaller. All right, so yeah, here we have my PC. So this is the PC that you're watching this, well, that's recording now. Here we have, let's just put it here at the bottom, the Raspberry Pi that this is running on. So this is running on a Pi 2B. So quite an old Pi, but you know, it's kind of perfect for things like this. All right, so here we have the router, like so. And then here we have a switch. So the PC is connected via Ethernet to the switch. The Pi also has an Ethernet cable going to the switch, and the switch itself is connected to my router because there isn't like a lot of port. There's not a lot of Ethernet ports in the router. And also the Pi, while being connected to the switch, also has a Wi-Fi card, just a USB Wi-Fi card. And let me just change the color to something blue. So yeah, the router is broadcasting 2 access points. So we'll just do kind of like this. This is just 2 wireless networks. So this will be kind of like the main network. God, okay, just main network. Then this will be, what you call it, the guest network. So what's happening here is, on the main network, you know, I have like my phones, my laptop, and all that kind of stuff connected to the main network. And on the guest network is all of my smart devices. So everything, all these like smart light bulbs, everything like that. And the Pi 2B's wireless network also is connected to here. So I'll actually show you this. Let me just put this here. So this is my SSH'd into my Raspberry Pi. And if I do IPA grep 10.0, what the heck happened there? Shit, what is the command for this? I forgot. Oh yeah, there we go. All right, there we go. So yeah, as you can see here, I have an IP address here of 10.0.0.71 on the Ethernet, and I have an IP address of 10.0.0.191 on the wireless thing. And this is connected to the guest. Even though they're both kind of the same IP, it's actually the guest, so I cannot actually. So if I just open up a terminal here, for example, and if I try to ping, so if I ping 10.0.0.71, which is the Ethernet port, I can ping it just fine. But if I were to ping 191, all right, for some reason that worked. I think it's because of the routing table. So on the Pi, if I do route A, I think it is route all. Hang on. What was it? Oh yeah, it was route N. Yeah, so I have like a bunch of shit routed over from the Wi-Fi connection so that the Ethernet can be accessed. So I think that's why I can ping it. But if I were to ping, let's see. Yeah, so if I were to ping, for example, my PC, and my PC is running at 1, oh no, it's running at 2. So this is using the VLAN to ping, and as you can see, I cannot, wait, ping, what is the interface? Okay, so it's capital I. Yeah, so I cannot ping my own PC from the interface VLAN 0 because it's on the guest network. But if I were to use ETH0, you see I can ping it just fine. So that just confirms it that I was able to ping this because of the routing table, which we'll get into in a bit. So yeah, this is how it's set up. And so what is happening here is when I make a request on my PC, for example, it will go through here, through the Ethernet to the Pi, and then the Pi over Wi-Fi will, you know, send a request to the actual, like the bulb and all the other stuff and all the plugs through the guest network. And then it will forward the response back through the Ethernet and then back to the PC. So that's how we can see. That's how we can see, you know, this sort of stuff here. So yeah, that's basically the explanation. So I suppose we'll go through the setup now as well. So yeah, for this, I wrote the setup guide so that it kind of presumes you're using Raspberry Pi, and it presumes you're going to be kind of deploying to the Raspberry Pi, or any Debian kind of base system. If you're using something else that's not Debian based, or you're just simply running this on your own, or without, like, you know, Raspberry Pi, just on your own system, you need to find like kind of alternatives for this, for all this kind of stuff. Now, at the moment, you actually just need Node.js and ARPing. Before I used to use Nmap to get the IP addresses instead of ARPing, but Nmap for some reason doesn't really find them that well. So yeah, I kind of rewrote the code to use ARPing more. So I'll show you what I mean by that. So if I go to W, and if I go into API, for example, oh no, not API, app, I think. Christ, where the heck did I, oh yeah, it was in the get IPs. Yeah, so before, to get the IPs of all the network, because you kind of need the IPs of these to forward them, and I'll show you what that looks like in a bit. But before I was using Nmap, but it didn't detect the MAC address of some of this stuff, So instead, what I'm doing is I have like a custom bash kind of function that goes through all of the IPs. So it goes from 10.00, blah, 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 100 up to 254, and it just gets literally all of the IPs that are there. Because my DHCP server on the router starts at 100, I can skip everything else before that, because everything else before that is using a static IP. But yeah, everything after that, including every single like Tapo device, is using a dynamic IP, which is why this script is kind of needed to get the new IPs basically. So yeah, yeah. So this uses AR ping now instead of the nmap, so you don't have to download these two files here if you don't want to. And you also don't need to download these two files here for the current version. So it's just npm or just apt install node.js and ARPing, and you should be good to go. Now, next thing is you'll need to create an env file. So as you can see here, I have a hidden env file here. So just create like a .env. Yeah, I won't show you how my one looks like, but basically it looks like this. So the API pass would be your email and password for when you log into the Tapo app. So it's exactly the same thing. Tapo is how much timeout is how fast you want it to time out. By default, I set it to 1.5 seconds, but you can edit this per device. So for example, if you have devices that are like downstairs and your router is upstairs, you would probably want to change the device that's downstairs to have, a timeout of 3000. So that'll be 3 seconds, and we'll go through that later. Right, next thing is the port. This is literally just has something to do with the URL. So here's the port number, it's port 3000. You can change this to whatever you want, provided it's, a valid port. And the bind address is the address of your Raspberry Pi. I would recommend that you use a static IP for this, because otherwise it'll get annoying. You'll need to change this all the time. So yeah, if we go into here and if we do, what was it? IPA. Yeah, so as you can see, my address is 10.0.0.71 for the Ethernet. And so you can set it to whatever your one is. And then just save that file and leave it there. Now, next thing is we need to create a file called config.json. So you'll see it here, but I won't show you it because it has like, all the MAC addresses and all that kind of stuff. So I don't really want to show you guys. But yeah, it'll basically look like this, like so. So the name can be whatever you want for your device. It's just whatever literally shows up here. So for example, as you can see, laptop would be laptop and all that kind of stuff. That's just the heading, for you to see what it looks like. And then here as well, if I were to run the monitor, yeah, so here you can see, the name here as well. So yeah, next thing, this is optional. I wouldn't recommend you set this, religiously, just set it kind of once. Basically, what this is used for is if the MAC address fails. So yeah, here's actually a good example. So my 3D printer, if I go here, as you can see, it's using the completely wrong IP address kind of domain or whatever. So as you can see, the rest of the stuff that's detected is on 10.0.0. blah, blah, blah. This is because the MAC address has been found for these devices, and it updated the IP based on the MAC address. Whereas on this thing, the MAC address isn't wasn't found, so it's using the default IP that's in the config, which is obviously wrong in this case. But yeah, since this plug is disconnected, it doesn't matter. Yeah. So yeah, this pass an email is the same thing as here. Now you can leave these as nulls, but if you're using multiple Tapo accounts, you can set your password and email here if you really wanted to, because each device has its own kind of separate API class. So we can do cool shit like this pretty much. But obviously, since here it'll be kind of in plain text, it's not ideal, so that's why I'm not really showing you guys. And so yeah, here's the timeout I was talking about. If you don't want to use the default timeout of 1 second or 1.5 seconds, you can change it to something bigger. The type, at the moment, I'll show you what the types are. So they should be in here. Yeah, so at the moment, the currently supported types are plug, bulb, and LED strip. Yeah, I'll probably add more if I buy more or if you guys want more. So do a pull request if you want more. All right, permissions is what you can do with this device. So for example, here, this is my monitors. And so I should not be able to turn off the monitors. Actually, instead, I should not be able to turn off my NAS. So if I were to turn it off, nothing would happen because I don't have, permissions to turn off my NAS. However, the laptop, I do have permission. So, I can turn it on. I can turn it off as well. So that's what that means, because, some stuff you don't really want to turn off. You just kind of want to monitor it. So that's why these permissions are there. And for the bulbs, so for the light bulbs, you can either have permissions for power and color. So if you only want to be able to change the color, you can delete the power. Or if you only want to be able to turn it off but not change the color, you can delete the color, for example. Yeah. All right. So let's see what else is here. So yeah, update interval. This is similar to the timeout, but it's how often do you want the device to update. So if the device is downstairs, or you just don't want to update it like a lot, you can put in a timeout here. So this will only update the device state every 5 seconds instead of every 1.5 seconds, pretty much. And the last thing, hidden, this just means this device, if this was true, this device would be ignored from the config. So when the server is reading this config.json, it will just ignore this section if hidden is true. This is handy if you have like some device that's disconnected and you just don't want to see it. So for example, like my 3D printer here is disconnected technically. So if I didn't want to see that, I could set the property to true and then restart the server, and it will not show anymore, basically. So yeah. Like I said, I recommend you put in the Mac. So to get the Mac, it's actually not too bad. All you need to do is you need to open up your Tapo app and then find the device that you're looking for the Mac, and then go into its settings, and then you'll see its IP address and you'll see its Mac as well. So yeah, that's that. All right, so yeah, some of the tools here, all of these have been kind of merged into sort of one. So I'll just kind of go through them. So yeah, get IPs we already talked about. This just literally gets the IP and MAC address, and then the server parses that output. Now, next thing is gen routes. So what this does is it reads your generated IP config file, and it generates routes for it. So it does sudo IP route add, and then the IP address via the net IP, and then device, whatever your device is. So yeah, that's how it does that. And this is also sort of auto-generated based on what you'll see later. And then the last thing, deploy. So if I open up that, yeah, deploy is basically just pushing all of this code to the Raspberry Pi. So it's using SCP to push all of the files, and then it's using SCP to basically build the server, and then all you need to do is just run it on the Pi. So this is quite handy, since you just need to run, the deploy script. You don't need to like SSH into your Pi at all, pretty much. You can just update it like this. All right, so next thing, we also have, so yeah, this I kind of explained how you do it. So yeah, there's a bunch of user interface. So the API and website is what you see here. Then you have CLI only. So if you want to run this whole thing without like a HTTP server and the front end, you can do npm run monitor. So if you go into the package.json, go into the scripts here. So this will just build and run this display all devices, which outputs a similar thing. Well, it outputs the exact same kind of table as this, except this table uses this server. So, if you do node monitor CLI, this uses this server, and just instead of displaying it like in the HTML table, it displays it in a shell. So yeah, pretty cool shit. But yeah, that's if you don't want to run the server. This is only really kind of useful if you aren't running a Raspberry Pi, pretty much. Yeah, and then API plus CLI is just what I was talking about. So running the server and then just running this monitoring thing here. And then we also have a systemd service, because Raspberry Pi uses systemd, and we might as well, leverage it. So there is a service here. So it's really fucking straightforward. Like, the only requirements are this thing can only be started after the network, and it will restart if something failed, and that's it. So what you want to do is you want to copy this into your etc systemd directory. Then what you want to do is you want to reload the services in this directory. Then what you want to do is you want to enable this service so that when your Raspberry Pi reboots, it will automatically start this service. And then you will want to start the service like right now, so that it starts running. And so what this service does, it basically just executes this service helper script. And this service helper script kind of combines everything from the other scripts. So you can see here, first it deletes this routes sh from your temporary folder. This is just used later on. It changes the user to guest, because by default, this will run as root, and we don't need it to run as root, nor do we want it. And then it will change the folder into here, so into wherever you have git cloned this thingy. I just called it smart home. And then, so what's going to run, it's going to get the IPs first, and once it's done that, it's going to generate the routes into the temporary routes sh folder. And then it's going to execute that generated script to populate the routes. So this is this thing here. If I go into here and I do route n, so this literally generates all of these routes for your devices. so that the Ethernet device can access them through the wireless device. Let's see what else was there. Yep, and then all it does is just does npm run server, which just starts the server on the Pi. And if we were to do this, for example, so system ctl status, shit, what was it called? Yeah, Tapo. Oh shit. Yes, so Tapo service. And if we just press enter there. Okay, it's trying to auto-complete something, but yeah, there we go. All right, let me make this a little bit smaller. So you can see the output of the server basically. So if I were to, let's say, turn off the office bulb. So you should see it there, turn off in the camera. It'll be off. And then if I go back into here and do the status again. All right, so it doesn't look like it actually updates this whole thing fully. Which is fine. I thought I would see, you know, get whatever, turn off endpoint. But yeah, oh yeah. And also one kind of important thing here is you'll see here in these things here. So initialize basically just means you want to initialize this whole kind of service again. So it will like go through and it will reconnect to all these devices. Reinitialize failed devices just means it will try to reconnect to these devices here, the failed ones. Update all just updates the state of all of them. So yeah, it's basically that. And keep updating just keeps on updating. Now there is also, if you click here, there is a restart systemd service. Now what this is literally restarts the systemd service. So I'm going to show you that in action. This is basically, you would use this for if you'll see that a lot of these IPs change, because they do change. They actually change like every 24 hours for me or something like that, around that. For some reason, I know it's quite annoying, but so as you can see here, I am constantly polling this. And if I press restart systemd service, you'll see that this crashes. And if I try to refresh the page is not available because the server is restarting. So this just takes a while. So what this is doing is it gets, you know, all of the IP addresses and the MAC addresses again to populate the devices. So it doesn't take too long. Yeah, like it's back now. And then you'll see that for the first time, there's nothing displayed because it hasn't been initialized. So all you need to do is just click initialize, then wait for a while. This takes a while because it's going to try to connect to each device on the network. And so yeah, there we go. We're back in action. So yeah, upstairs for some reason got timed out. So if we reinitialize failed devices, there we go. So yeah, there's a good example of reinitializing failed devices. So the upstairs thing, bulb, timed out after 1.5 seconds. So I might want to increase that to like 2 or 3 seconds, you know? So that way it gets it all. So yeah, that's basically how it all works. I think it's pretty cool. I think it's pretty cool that it's, you know, standalone. So yeah, this thing is on my GitHub. It will obviously be not private when this video goes live, but because I just kind of finished it up today pretty much. So yeah, you can see it's kind of a mess of languages, all of them. Yeah, mostly TypeScript, so yeah. Yeah, that's bad. Give it a good star, give it a watch, give it a fork, give it all the stuff, baby. So yeah, I don't know how many of you guys will find this useful. Probably like maybe 1 in 100. But yeah, have fun with it anyway. It's quite handy, monitoring this thing. I can just kind of leave this on one of my monitors, just kind of running all over the place. Let me just turn on the light in my office. There we go. You'll be able to see it there nicely. Let's change the colors, something a little bit less bluish. Yeah, that will do. Alright. Yeah, I'll need to fix up some shit in the front end as well, because apparently it's not hiding it. Yeah, that's not great. Okay, that's a nice bug there that I'll fix later. But yeah, thank you boys for watching, and I'll see you next episode. Bye bye.